Dear students, today we will discuss Rutherford scattering formula. Rutherford scattering formula. You have already read about the Rutherford formula or Rutherford scattering. So, it is a scattering by alpha particle with heavy nucleus. Just as simple, it is scattering or collision. So, let the first particle, that is heavy nucleus, is placed at this point A, heavy nucleus. The charge on the nucleus is Ze. You know that E is the charge and Z is the atomic number. So, Ze is the total charge on the nucleus, and alpha particle is coming from this side towards this particle, but it will scatter due to force of repulsion by the nucleus. So, this nucleus is very heavy nucleus, and alpha particle is, you know that it is helium particle. So, alpha particle consists only 2 protons, but in case of heavy nucleus it consists of large number of protons. So, why we prefer this heavy nucleus, or we use this heavy nucleus? So, heavy nucleus is used for to prove that the nucleus remain undisturbed, or this nucleus remain at rest after scattering or after colliding with the alpha particle. So, alpha particle is coming and it is moving towards this A side, this side, but due to strong force of repulsion it distracts its path. So, it will move from this side to this side. So, it will not reach very near to A or this nucleus. It repel, this nucleus repel that alpha particle very far from the distance from this side. So, this is a large distance. So, it is called interaction. It is not collision physically, it is basically interaction between 2 particles. Now, we have to find what path is followed by the alpha particle. So, this is called trajectory or path followed by the alpha particle during the interaction with the heavy nucleus. And second one is, if we draw the asymptotes. So, what are asymptotes? Asymptotes are basically the line which is passing and meet at infinity. So, similarly, this asymptote for second, that is scattered path, become this, and it is called asymptotes. So, asymptote means the line which is parallel to the path of the particle and meet in the particle at infinity, and both these asymptotic lines will meet at this point. Let this point is O point, and the line joining between this particle and this point of joining of the asymptotes is drawn with straight line. So, this is any line which passing through the heavy nucleus and the intersection of the asymptotes. Now, the angle formed between these 2 asymptotes is phi. So, this phi is called angle of scattering. So, we can draw here y axis. So, this is origin, it is x axis, it is y axis, So, we can solve this article by using these two axes, and we will apply the plane polar system r theta system to solve this article. Now, the perpendicular distance from this A point on this line, that is asymptotic line or incident particle line, is called impact distance or impact parameter. So, this A and M is called impact parameter. So, it is nothing, it is just perpendicular distance from the nucleus on the line which is incident from the alpha particle towards the nucleus. This is impact parameter, or it is simple distance, AM distance. So, it is mostly written by P or B. So, I am using the symbol P for impact parameter. Now, what are our aims in this article? So, our aims are, first we have to find the path followed by alpha particle. So, what are the aim of this scattering? Number 1, path followed by this alpha particle during interaction. So, we know that the path followed by it is hyperbola. We have to prove the equation for hyperbola because it is hyperbola. And second one, we have to find the relation between angle of scattering and impact parameter to derive the relation between angle of scattering phi and impact parameter p. Second one. And third one, we have to derive the expression for differential scattering cross section. Third is expression for differential scattering cross section. So, we have to find these three parts by using Rutherford scattering expression. So, first of all, we will prove the path followed by alpha particle. So, what will be the path? We know that the path followed by the particle is hyperbola, but we have to prove it. First one is, what is the path followed, or equation of trajectory? We have to prove it. So, for proving the path followed, we will use the concept of force of interaction. We know that it is nucleus, that is having positive charge. It is helium particle, alpha particle, it is also positive charge. So, when one positive charge is approaching towards other positive charge, there will be force of repulsion, and that force of repulsion is, that is a Coulomb force, that is F is equal to any constant into Q1 Q2 over R square. You know that here it is 1.4 pi epsilon naught in SI system, but in CGS system it is F is equal to any 1 into Q1 Q2 by R square. So, what is Q1? Q1 is ZE, Z into E, and Q2 is 2E, because in case of helium the atomic number is 2, that is Z is 2 and E is the charge on one proton. So, 2E into ZE over R square. So, this is force, and it may be written as 2Z E square upon R square, it is force. So, this is equation number 1. F is equal to 2Z E square upon R square. So, this is a force or Coulomb force in CGS system. So, the alpha particle is moving under this Coulomb force. So we know that this force is inverse square force, and the article become the motion of the particle under inverse square force. So now we will find the path. So path followed by this particle. So we will use the concept of this force. So first equation, that is F is equal to 2z e square upon r square. This is equation number 1. This is Coulomb force. And we know that when the particle is moving under inverse square force, we know that the path followed by the particle is conic path. So we know that the path followed is conic path. So we know the equation for conic is 1 by r is equal to 1 by L into 1 plus epsilon cos theta. So this is the equation for conic, theta or theta minus theta naught, where L is equal to this L. Latest rectum, it is mu k over L square, and this epsilon, that is eccentricity, is equal to 1 plus 2e L square, 1 plus 2e L square over mu k square, So this is eccentricity. So this formula we have already proved in the previous articles. So first equation is equation of force, that is Coulomb force or inverse square force, and second one is equation of conic. So these two equations, and the values for L and epsilon are these. But our purpose is to prove the path followed by the particle, alpha particle, is conic hyperbolic path. So we have to prove epsilon is greater than 1. You know that when epsilon is greater than 1, it means the conic become hyperbola. So when we prove it, the value of our epsilon is more than 1. So when it is confirmed that this term is positive term, because 1 plus any positive term is more than 1, and under root of more than 1 is also more than 1. So we have to prove it that this term is purely positive term. So how we can prove it? So we prove it by using the values of k and L, in the value of L or in the value of eccentricity. So what is k? Means our next part is only deal with this eccentricity. So we are only concerned with this term 1 plus 2e L square over mu k square under root. So what is L and what is k? So you know that what is k? K is 2z e square, because from equation 1 F is equal to 2z e square upon r square. So we know that F is equal to 1 by r square, and it is constant, the proportionality constant, it is k. So k is 2z e square, this k is. And similarly, what is value of E? So we know that E is half, what is value of L? Well, so we know that the value for L is mvr. You know that L is equal to mvr, angular momentum, linear momentum into r. What is m? M is mu. What is velocity? Velocity is u. And what is r? R is p. So in this article, I am using mass as reduced mass. This mass as reduced mass, velocity as u, and r is distance, that is impact parameter. I am using the distance as impact parameter. So L is mu u into p. Now we will convert this mu u, the value of mu u, the mu u is 2 m e. mu u is 2 mu, sorry, 2 mu e under root. So, on putting the value of this mu u as 2 mu e, and finally we get L is equal to P into this L become mu u, its value is 2 mu e under root into P. So, this is value for L. So, it is K, it is L. On putting these values K and L in this equation, and we will finally get eccentricity is equal to 1 plus 2 e into L square. L means square of this term, that is 2 mu e into P square over mu into K square, that is 4 Z square e raised to power 4. And on solving, this eccentricity become on cancelling, and the terms 2 into 2 become 4, and 4 is cancelled with 4, and we will get 1 plus E p upon Z e square, 1 plus E p on Z e square raised to power 2. You will find this value on simplification. Now, it is clear that it is 1 plus, it is square of anything, So, we know that square of any real number is always positive. Square of any real number is always positive. So, it will become 1 plus any positive quantity. This quantity is purely positive because it is a square of any real number. So, 1 plus positive quantity means more than 1, and hence epsilon is more than 1. So, now it is confirmed that the value for eccentricity is always more than 1. So, hence prove that the path followed by the particle under inverse square force is hyperbola. This is our first part. We will prove the second and third part in the next lecture. Thank you very much.